Okay, so this is a desmos simulation for projectile motion. So let's see. Okay, so I have set the height 0 and the initial velocity u, and c is the angle. C is the angle with the horizontal, and then I have set the equations and plug it here, and I get this kind of trajectory. Well, now let's see. The effect on trajectory for the angle. C is the angle with the horizontal. So when C is 0, the maximum distance covered is 0. Then this distance increased. This distance increased, and at a certain point, it's maximum. And this is actually pi by 4. When the horizontal distance is maximum, then the angle is pi by 4, and then it again decreasing, and now it becomes 0. Well, so now we can increase the height. Let's throw this object at a height of 50 meter, and now let's run the simulation, or let me increase the angle. So I have set the final time. So this is actually the final time. I have used the equation like this. I find the time when the object will hit the ground, and the formula looks like this. So I have plugged this formula here at the final limit of the time, and that's why the simulation stopped when the ball hits the ground. And I could make the trajectory so smooth if I take here a small interval. So you see the trajectory is now so smooth. Well, so I have decreased the width of the line. Can I throw to the negative side? Oh yes, I can. Then sin C should also be greater than pi by 2. Okay, so let me write here pi. So U is negative now, and angle, the C is the angle which is greater than 90 degree. I think it's not working. Well, U is positive, but angle is greater than 90 degree. Yes, now it works. Well, let's see from 0. Okay, so I can throw it to the negative side, or in the left side. Now to throw this object upward, the value of this angle should be pi divided by 2. Okay, that is the maximum position, and then it will hit the ground. let me put this 2.1 or 2.01. Zero 5. Okay,